Okay, pre-calc. So this video is going to be all about 4 different sections. We're going to throw it all into one. It's just going to be a ton of formulas, get it done, and then the next several days in class we'll talk about how to apply these formulas. So really you're going to have a lot of notes to take right now, but we'll make it quick. Okay, so first stuff we've actually already seen before, fundamental trig identities, and again we're talking reciprocal identities, so sine being the reciprocal of cosecant and cosecant being the reciprocal of sine. Cosine and secant are reciprocals, and then like we've talked about, tangent and cotangent are reciprocals. Okay, so those are the reciprocal identities. Then we have the quotient identities, which tells us that tan is sine over cosine and cotangent is cosine over sine. And then also ones that we have talked about already, the 3 Pythagorean identities, sine squared plus cosine squared equals 1. And then we have the other 2 that are essentially just manipulations of that. 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. Okay, so these are all really the same thing, and we're going to talk a lot in class about switching things into terms of sines and cosines when we work with identities. And if we did that with these 2, you'd really see how identical they are. Okay, even and odd identities, we have also talked about this. So remember, only cosine and secant are even identities, so the negative angle really means nothing in those 2. On all 3 of the other ones, you just pull, or I'm sorry, all 4 of the other ones, you pull that negative sign out in front of each one. Okay, so cosine and secant again are even, and the other 4 are going to be odd. So on the odd, we pull that negative sign out in front. On the even, the negative sign just becomes positive. Okay, then these are what's going to be new for us. So we're going to need that sum and difference of 2 angles. So you see here we have cosine of 2 different angles. We're just calling them alpha and beta. In our formula, cosine alpha, cosine beta, minus sine alpha, sine beta. So one easy way to kind of remember this, or one thing that might help, is when your cosines, when your trig functions are the same, you see your sine is different. We go from adding to subtracting. And likewise with our cosine, we keep our cosines the same, but we go from subtracting to adding. And it's flipped when we do sine addition and subtraction of 2 angles. You see that the trig functions change, but the addition stays the same here. So sine alpha cosine beta plus cosine alpha sine beta. And likewise, when the trig functions change again, our subtraction stays subtraction. Okay, so there are your 4 sum and difference of 2 angle formulas. Make sure you get those down. Double angle formulas, so we're going to have 3 of these, 1 for sine, cosine, and tangent. Sine is a nice easy one. 2 sine theta, cosine theta. We just bring the 2 out in front and add a cosine theta. Cosine of 2 theta, cosine squared theta minus sine squared theta. And then tangent of 2 theta. 2 tan theta over 1 minus tangent squared theta. And in fact, cosine of 2 theta has 3 formulas in total. And essentially that's because of our Pythagorean identities. So in other words, we could substitute something in for one of these 2 from our Pythagorean identities, which means, remember we said was sine squared theta plus cosine squared theta equals 1. If we solved one of these for sine or for cosine and substituted in, we'd get our 2 other formulas, 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. Okay, moving on then to our half angle formulas. So if we have sine of alpha over 2 plus or minus the square root of 1 minus cosine of alpha, and one important note to make here, this depends on alpha's value, meaning what quadrant are we in. So if alpha is positive or negative, that's going to determine whether this is positive or negative. And similarly, we have cosine of alpha over 2, again plus or minus 1 plus cosine alpha over 2. So you notice the only difference in these 2 is that 1 is minus and 1 is plus. And these again go back to our Pythagorean identities. And then finally, tangent of alpha over 2 is going to have 2 formulas, plus or minus 1 minus cosine alpha over 1 plus cosine alpha, or just 1 minus cosine alpha over sine of alpha. And the last one then, another one for tan of alpha over 2 is sine of alpha over 1 plus cosine of alpha. So it's just, again, we're manipulating these same Pythagorean identities to get all of these other options. And finally, then we have our power reducing formulas. So sine squared of theta equals 1 minus cosine of 2 theta. Again, this has to do with our Pythagorean identities. If we solved this for cosine of 2 theta formulas we had before, we could plug stuff in. And vice versa, cosine squared of theta is 1 plus cosine of 2 alpha. So you see, again, the only difference here is 1 is minus, 1 is plus, kind of like our half angle formulas. And then tangent squared of theta, 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. Okay, so that is all of our formulas. I know that is a ton of formulas, and you probably have some cramps in your hands now from all that writing. But really, that's going to be the majority of the notes and everything we're going to have to write down for the rest of this chapter. Now it's going to go into proving identities. So we're not going to do much with actual values now. It's going to look a lot like just having variables in there and proofs, some stuff that we did in geometry, although not images like we did in geometry. Okay, so we will see you next time in class, where we'll come up with a set of hints that's going to help us with our identities. Things like changing into terms of sines and cosines and working with the most complicated side, issues like that. All right, see you next time.